Hello guys, welcome back to my channel. My name is Shishwa Saital. I hope you all are doing fine. Let's solve today's problem for lead code. The problem name is as far from land as possible. Okay, it's a medium problem. Let's give a like. The problem is saying given an into n grid contains only value 0 and 1. So 0 and 1, so binary, where 0 represent the water and 1 represent the land. Okay, find a water cell such that the distance of the nearest land cell is maximized and return the distance. So what we have to do, we have to find a water cell such that its distance to the nearest land cell is maximized. If no land or water exists in the grid, return -1. Okay, the line used in the problem is a Manhattan distance. The distance between two cells are x0, y0, and x1 and y1 will be x0 minus x1 plus y0 minus y1. Okay, let's understand this problem. So we are given here a grid which is 1 0 1 0 0 0 1 0 1. So 1 is here, 1 is what? The 1 is here represent land. It represent land. And 0 represent water. I will take it blue here. 0 represent water. Okay, so let's make a grid here. We have here 1 0 1 and 0 0 0, and here we have 1 0 1. See here, if we go here, the nearest land is here, only 1 here. So this is land and this is water. The nearest is here 1, and as we can see here also, here the nearest is also 1. So this cannot be the answer here. So by this only have one distance. And let's check for this guy. Here nearest land is here 1 and we have to go up, or here we have to go up and here this one, or if we go down we have to go here or here. This is the nearest land. So distance is here how much? 1 and 2. So here it is 2, and here it is how much? Here it is 1, and here also it is 1, and here it is also 1. So what we have to do, we have to return the maximized distance. So here by visualization we can see the maximum here is here 2 1. We can go 1 and we can say here 2, and if we want to go from here, and here also we have 2, and if we want to go from here, we can also go from here. So we have to see, we can only go top, right, left and bottom. Okay, we can't go diagonals, here. We only can go top, right and bottom. Okay, so let's understand like how we can solve this. So here by visualization we can see the 0 is the closest one. Here this guy is the closest one. This guy is the closest. This guy is the farthest one from the line. So 1 and 2, and these all are closest one to the line. These are 1 and this is only getting 2 distance from all the side. Okay, so let's see this how we can solve this problem by DP. How we can solve it? By using dynamic programming. So let's see how we can do it. So first what we'll do here, first we'll make a grid. So 1 0 1, and another one is 0 0 0, and the last one is 1 0 1. So what I will do, I will first do top and left. Okay, so what is top and left? See, I have one condition. If the land comes, then I have to skip it. I have to skip the process. I have to skip the process because so here the question told we have to find the water cell. We have to find the water cell. So we will skip the land cell. Okay, this is part clear. And second step, what we have to do, if we find the water here, so what we'll do, we will go to the top and see what is there any land here, and we'll go to the left side. Is there any land here? Okay, so let's see. And if we have a land here, we will rename this as the lowest value here. Okay, let's see. Okay, I hope you understood this one to approach. If we find any land, we will reassign this number. Okay, find. Let's understand this. At first, what we have, we will go from, we will first do top and left side. So at first we have 1. So what we'll do, if 1 comes, then we have to skip it. What we have to do? We have to skip it. Now we will go to the this one, this another guy. So which is 0 here. So here we have to check, is this land or water? We can see it is a water because we have 0 here. Now what you have to do? I have to see, is there any top here? No. Is there any left side for this guy? Yes, which is land. So what I will do? I will reassign this as, I will redesign this as 1. So what is the here? 1 plus 1. Okay. So this will be how much? 2. But so anyone want to reach to this land, anyone to want to reach to the this land, they have to take 2 distance. Okay. I hope you understood why 2 come. So if assume this guy want to reach to the this distance. So if I put it here 1 only, it will take only 1 distance, but in real case, he will travel till here and here. So it will take how much distance? It will take 2 distance. So that's why we will do plus 1 to reach to this here. It will take plus 1. I hope you understood here. So this will be equal to now 2. Next will be equal to 1. So if it is 1, then we have to skip it. Let's come for this guy. So what we have to do? We have to search for top and the bottom. So this is 0. What is this here? Top. So it is 1. So if this guy want to reach here and he should travel to land, so it will take how many distance? It will take 2 distance. So here 1, here is 1 plus 1, which will be equal to 2. I hope I'm clear here. Let's do for another thing. This one is also water, and I will see. So here it is 2 and here it is also 2. Which is minimum? Both are like 2, 2. So no minimum here. And see, if I want to reach this land, let's assume if I want to reach this land from here, how many distance it will take? It will take 1, 2, 3, or 1, 2, and 3. So here how many distance happens? It happens 3 times. Okay, that's why we are doing here. I will just rub it. That's why we are doing here 3 times. Okay, to reach to the nearest land, it will take 3 distance. Okay, let's go for another thing. This is also water. So what we'll do? So we have to search for 1. We have nearest 1 here and nearest 3 here, and we can see which one is the smallest. 3 is the smallest or 1 is the smallest? Obviously 1 is the smallest. So what we will do? We will change the value 1 plus 1. So why 1 plus? Because we have to travel the distance here. So it will be equal to how much? It will be equal to 2. Okay, let's go for the down, because if we have 1, we have to skip it. Let's go for this guy, and I have to see what is the top here. Top is here 3. And what is the left side? It is 1. So which is the smallest? Obviously 1. So what I will do? I will say here the lowest land plus 1, which will be equal to 2. And here it will be 1. So this is the DP for bottom. This is the DP for, we will do 2 DPs. This is the DP for, what is this DP for? Top and left. Okay, so we'll do 2 DP. This is 1 DP, and another DP. What we'll do? We will search for bottom and right. We did it for left. Now we will do for right. So here same case. If I get 1 here, I will skip it. If I get 1, I will skip it because it is land. Okay, so here we got 1. I have to skip it. And here what is that? It is 2. It is, if I have it, if it is not 1, I can see which is the nearest land. So what I have to do? I have to search for bottom and right side. Here which is the lowest here? Here lowest is here 1. So 1 plus 1 will be also equal to 2. So it will be reassigned as 2 only. It will be it will be reassigned as 2 only. Okay, I will see if this has the lowest, and I will reassign this as the lowest. I hope I'm clear here. Let's go for another thing. This is 1. I have to skip it, and here this is 2, and I have to see the right side, which is here 3, and what is the top side, which, sorry, no, bottom, right? So what's the top one side, bottom side, is this 1. So what I have to do here, I have to consider the lowest value, which is 1 plus 1. So it will equal to 2. And I have to see which one is the lowest here. Both are equal. So what I will do, I will reassign this as same thing 2. Okay. Now we have 3. Now we have 3 here. So what is the here? We will search for bottom and left side. In both the case, we have 2 and 2. So here the lowest will be 2 plus 1. Okay, it will be 3, and 3 which one is minimum? 3 is minimum, or 3 this 3 is minimum? Both are equal. So I will just reassign this as 3. Okay, and next is 2 here. Here is 1 and here is empty, so we don't need sorry, we have to go bottom, right? Sorry, we have to go for bottom, which is 1 here, and the right side is empty, so don't need to do that. So 1, so 1 plus 1 will be equal to 2. So we will do reassign this as also 2. And next is 1, so we will skip it. Next is 2. What we will do here, we will search for bottom, which is nothing, and we will go for right side, which is 1. So 1 plus 1, which is also equal to how much? 2. I hope I'm clear till here. And at last, what we'll do, after doing DP for top, bottom, right and left, after that what I will do, I will iterate to the array and find the maximum possible answer. A maximum possible answer. Why I have to find maximum? I have to return the distance maximized cell from the line. Okay, so I will iterate to the array, and I will find the answer as 3. I will find answer as 3. And what I have to do here? But answer here was 2. But you are saying you are getting 3. This is wrong, right? See what I told here. If anyone want to reach the land here, nearest land, it will take how much time? It will take 3 distance. If this guy want to reach here, it will take how much distance? 3 distance. But if this guy, but I will change the color. If this guy want to reach the nearest lesson, is maybe this, maybe this, maybe this, maybe this, how much time it will take? It will take here 2, it will take here 2, it will take 2, it will take 2. It will not include this distance, it will not include itself distance. So it will be 3 minus 1, which will be equal to 2. I hope I'm clear here. Let's do the code. Whatever the step we solve, we will do the code same thing. Okay, first what we'll do here, first I will find the length of the grid, and column also, row and row column. In this case both are equal, but like here both are equal, so no need to do m also, but I am doing it for more clarity. Okay, after finding it, I have to say, so here if it go up, so it will be x, right? So nothing will be there. So what I will do, I will simply put any value. At best scenario, I will put x equal to m plus n. Okay, this simple value, so no need to stress about this. This simple, like if it is go outside the grid, so we will just assign it x, and I will find the minimum also, so x is not included. So let's see what I will do here. First up, what we'll do, we will use here, what we will use here, we will use here what? Top left. Okay, so top left. Okay, we will use for loop, int I equal to 0, I should be less than n, I plus plus, and same thing for j, for int j equal to 0, j should be less than m, j plus plus. Okay, so what I will do, I will first I will do, if it is 1, then what I have to do, I have to skip it. If it is 1, what I have to do, if grid I and j is equal to 1, then what we have to do, we have to skip it. For that we will use continue. Okay, we will skip this for loop. After that, what I have to do, if it is not equal to 1, then what I have to do, I have to assign top and bottom. Okay, first I will say int top equal to x, int we are going at left equal to x. Okay, After that, what we have to do? I have to see in this some cases it's a edge problem here. I can't simply say here top is equal to grid. So if I want to go to the top, what I have to do? I have to do I minus. If I want to go to the top. I can't simply say I minus 1 and j. Why you can't say? It will show what error? Here in this case, it will show what error? Out of the bond. It will show out of the bond. So what I can say here, I will use a if condition to remove the error. So I will use if I minus 1 is more than or equal to 0, then only do this operation. Okay, same thing I will do for the left side. If it is here, if I just see if it was here, we can't go left, it is an out of the bond. So to tackle that, what we'll do? If j minus 1 equal to is more than or equal to only 0, then do one thing, just do left equal to grid. So to go to this side, what we'll do? To search for this side, what we'll do? J, we just rub this to make it more clear. We have 1, we had here 2, 1, 3, 2. So to go to the left, what we'll do? J minus 1. Okay, so I will remain same and j minus 1. After that, what we did here? After that, we found out which is the minimum value, which one was the minimum value. So same thing we will do, and we'll reassign it to the grid I and j. So we will reassign it to the grid I and j. Okay, so what is the value here? We have to do mat, we have to use mat.function top and left. After that, what you have to do? You don't forget this one, right? We didn't forget this one. What we have to do? Plus 1, because to reach here we have to do plus 1. Okay, so we did it for top left. So same thing we will do for bottom right. Okay, so we'll do for int I equal to 0. No, see, we will do for bottom. How we'll do it? We will do it from here. Okay, so what we'll do? We will do it from here, and we will go to the 0. So I should be equal to n minus 1, and I should be more than or equal to 0, and I minus. And same thing for this one, for int I j is equal to m minus 1, j is more than or equal to 0, and j plus minus, sorry. Same thing we have to do for here. If we find out this guy, what do you have to do? You have to just continue it. Okay, now we have to see int bottom. I will just say here x, and here int right equal to x. What is x? X is the arbitrary value, maximum value. Okay, after that, what we have to do here? We have to do same thing here, but in this case it should be less than n or m. Okay, why less than n mm? If you go right, it will go out of the bond, so it should be less than n. And if you go same thing for down, it should be less than m. Okay, so same thing we'll do here. If I plus 1 is less than n, then only do this operation. What is the operation here? Bottom is equal to grid I plus 1 and j. Same thing for this. If I plus 1 is less than I not plus 1, j. Same thing we'll do for m. What we have to do? We have to say right equal to grid I and j plus 1. Okay, after doing this, now what we have to do here? I have to reassign the grid value now I and j. So here we have three value. We have three value. What are the three value? One is bottom, one is right, and which is already there here. What we'll do here? We have to find a minimum value here. So mat dot minimum first what we'll do, we will assign its own value, copy this, paste it here. I'm quite lazy here for this, and we'll do some same thing for this, max dot minimum. So what will be that? Bottom comma right, and we have to do +1. Okay, this is right, and we will say okay. So after that, what we have to do now, after doing bottom and top left and bottom right, then what we have to do here, what we did here, we found out the maximum value. So first I will assign this max equal to minimum value. So integer dot minimum value, and I will say I will iterate to the array. I will simply do this guy. I will iterate to the array and paste it here, and this guy and this guy. Okay, and I have to say max equal to max dot max comma the grid value. Whatever the grid value comes, we have to do it. Okay, after that, okay, this is the problem. So there is a problem here. See, there is a problem here. If there is no land here, in this case there was no land here. So in this case there was no land here. Not this case. Let's say if we don't have any land or water. Let's assume if we don't have any land and water, any land or any water here, 0 0 0 0 0 0 0 0 0 0 0 0 0. So what we can say, it will give some estimate value. It will give a topmost value, which is here x plus 1, which is 4. 4 plus 4, which is 8. It will give an output at is, but it should be equal to -1 because there is no land. Why it will give it? Here we consider here has 8 here. So we have considered bottom and right has x plus x. Okay, so it will give us at most as 8 or 4. Okay, so to see here, to tackle this here, we will use if condition. If x, not x, max -1, y -1, I told you about here, y -1 we have to do because it have to reach here. -1 is equal to what is x here? X plus 1, or max -1 is equal to 0. Then do one thing, return -1. Okay, if that is a not case, then return max -1. Let's run and see if there is any problem here. Yeah, it is getting passed. All the test case is getting passed. Let's submit and see if you have any time error or not. Yes, if we don't have any time member and it beating 100%. So we can say for this problem, DP is best approach. We can use a BFS, but DP is a beginner level and it is very easy to understand also. I hope I'm clear here. I hope this algorithm is very easy to solve this problem. And if you still have any doubt, please do comment. I will surely help you. And if you like this video, please give a like. And if you didn't subscribe to my channel, please consider subscribing and keep coding. Thank you for watching. Bye.